Right.
Okay, so just a reminder, my name is Amy and I'm an intern at Career Chats.
Okay.
And yeah, we're here to start an interview about your career as a quantum theoretical physicist. So my first question for you is, what has your career journey been like?
My career journey has been quite interdisciplinary in a sense that I started with career ambition in astronomy and astrophysics since my high school. But then, while reading about astrophysics, I quickly realized that quantum mechanics is playing a huge role, even in understanding how stars are formed, uh, to understand the nuclear physics. And so I was quickly fascinated to quantum physics. And when I started understanding nuclear reactions and how alpha particles are emitted from the nucleus, it was more and more puzzling to me because, like, the conventional ideas of Newtonian physics cannot capture all that. And that's how I was attracted to quantum mechanics, is essentially trying to understand how star works and how nuclear physics works. So my essential interest was in high energy physics. But then during my first year undergraduate, I was introduced to these ideas of Young's double slit experiments and quantum interference effects, and then quantum computing. So I was quite fascinated by the phenomenon of interference. And that was another motivating factor for me to actually learn quantum mechanics and kind of appreciate the applicability of quantum mechanics in various domains. So, but my journey was also interrupted in between. In a sense, I was more interested in applying quantum mechanics to medical problems, and that's how I also learned some biomedical physics and how the medical devices like computed tomography or magnetic resonance imaging works. And that gave me a further boost because then I realized that there are these beautiful applications of quantum mechanics on one hand that we use in our day-to-day life, and there is this mysterious behavior of the quantum particles at that scale, which has like applications are fine, but that mysterious behavior, it's still kind of puzzling because there are two schools of thought here in quantum mechanics. I mean, some people believe that quantum mechanics is incomplete and certainly requires more complete theory to describe nature. Some people believe in that no, quantum mechanics is just the way it is, and you don't dictate logic to nature. Nature does whatever she likes to do, and no matter how weird it is, you have to live with it. So I was kind of fascinated by this philosophical debate as well. So my motivation comes from uh, the applications of quantum mechanics uh, to the philosophical debates in understanding the nature of reality. So it was kind of a mixed journey to quantum mechanics. And this journey became more meaningful when I started doing my PhD at the University of Toronto because things are exciting on one hand. You read about them in science and science fiction, movies or documentaries. But when it comes to doing the actual physics, you cannot you theoretical physics, and especially you have to have the background in mathematics, right? So your journey, you start with the exciting journey and curiosity, and now the next part of your journey is to acquire actual tools so that you can continue your journey. See, that's the second part in the journey that you do in your PhD, is that you acquire tools so that you can continue this exciting journey. And today, I'm very proud to kind of mention that even though I'm a quantum theoretical physicist, I'm also doing experiments in quantum mechanics. So I work in the lab, I'm learning how to do experiments as well. So it's an open journey. Let me tell you one thing. The journey never started with the career ambition to begin with. Journey was just trying to understand astronomy, astrophysics, how nature works. And if you have an open mind and curiosity, it leads you through a career of a theoretical physics now to working in the lab and supporting the experimental effort of also using the theoretical expertise. So it's kind of it's an evolution process.
Yeah, that was such an interesting journey of yours because I can see that you kind of like wandered off in different areas of physics before you finally reached what you are now.
Yeah.
And I thought that was just really interesting, like how many fields in physics there are, and that there's theoretical and experimental physics and so many different kinds.
Yes.
So in the future, I could become either a theoretical physicist or maybe even an experimental physics physicist, and I could be anything.
You can, what I can advise is like if you keep your mind open to everything that is happening around you, okay? Because when you develop an ability to do analytical and logical thinking, that is the purpose of science, right? You develop a scientific attitude. And then you can analyze every phenomenon around you, whether it be natural or whether it be social and political or economic. That scientific attitude of exploration kind of helps you in analyzing many things happening around. So I wouldn't say that I don't think people can have an MB. Of course, you know what your orientation, but if you're mathematically oriented and you know that from the beginning that you're highly mathematically oriented and that's what you want to do, definitely you can do your journey to become a theoretical physicist. On the other hand, there are some economic factors which also can impact your journey. So, for example, funding to science, right? I wanted to be a high energy physicist, but the funding to high energy physics and the job prospect, like the number of academic positions in that area, is not always ample, you know. Uh, so I wanted to become a high energy physicist, but then I realized that the tools that I learned in high energy physics can be applied in condensed matter physics and then quantum computing. And then you need quantum computing to simulate some phenomenon in high energy physics. So these things are, and then I was also interested in quantum biology, how birds fly, how do they navigate the direction. So all of these problems in nature, you never know, like you might choose to work in the medicine and you can come up with a problem that requires quantum mechanics. That can happen.
It's
So
very interesting to say
yeah,
because just by observing the world around you, you could develop an interest in something that can lead you to become different physicists, right?
yeah, absolutely.
Yeah. Okay, so that was the first question. My next question for you is, what is a fun fact or an interesting piece of information about your career?
Interesting piece of information about my career from the fun point of view is you get to do things which very few people can do. So, for example, you hear about Schrodinger cats all the time, right, in the literature. Now we are working in the lab to actually prepare those states. Now, when it comes to actually preparing those states, you really have to do theory to the possible extent. You have to find how to prepare it in theory, and you have to translate that in terms of a protocol, and it's a protocol that one should be able to implement in the lab. So the fun thing about doing a theoretical as a theoretical physicist for experimental team is to understand the constraints in the experiment, what they can do, and then coming up with clever solutions so that you can do it with as simple protocol as possible. That's a very difficult, but I think things which are very difficult, it involves fun. So that's one part of it. Second part of it is that I work with students, I co-supervise students, and they come up with interesting problems and challenging questions. So the another thing is that if you are a theoretical physicist in the academic settings, you always get inspired by challenging questions from students like you, and that keeps your journey going and becoming more and more exciting. So those are the two fun things about the job that I'm doing currently. Uh, let me just summarize this. Maybe like you do a there are two things in life. You do a job and you get paid. And then another thing is you you get to do what you like to do and you get paid for it, right? So that's the most satisfying and fun thing about it is that you like science, you're doing it, and you're getting paid for it. And apart from money, there is this satisfaction that whatever work that you're doing when you publish papers and communicate it with other people, there is this satisfaction that you get by understanding something. You develop a different kind of confidence through it, through that process, that you can understand something theoretically. Your theory works can be demonstrated in the lab, and you can educate other people and you can refine your worldview. That's the more satisfying part of the process.
Yeah, so I think your idea of like the fact that your career keep like what you do in your career keeps your career alive is really interesting because it basically keeps you going on with your career, right?
Yeah,
Because you working with students kind of just like brings you happiness and satisfaction that allows you to continue your career.
yeah,
And I
and it's a
think that's
feedback.
really interesting.
Yeah, and it's like a feedback. So
Yeah.
you feedback with yourself, right? It feeds you back and kind of positive feedback. It amplifies your ambitions.
Mhm. So, another question that I have is, what are like the key milestones that have led you to where you are today? So, were there any key landmarks in your life that has led you to specifically where you are today?
Landmarks in a sense of scientific achievement or
It could
uh,
be anything, anything that you consider a landmark in your life.
uh, particularly when I was working on, not working on, but when I was fascinated by astronomy and astrophysics, I built a small telescope uh, using a PVC pipe, essentially. And I was able to I was able to do sky watching for other people. So I could invite people in my terrace and I could show them planets and moons and explain them how things work. So, I mean, that was the first small device that I built, and I think that forms that constitutes a motivation for me to kind of go ahead in life because you can build something and you can show it to people. But another landmark achievement, if I were to talk about it, that came when I worked on quantum biology. Uh, and this was the work that I did in UK, where we were working on how birds navigate by sensing the Earth's magnetic field. And we were come able to, so there is a model for that. It's called as a radical pair model. And we were able to come up with an alternative model that didn't require radical pairs, but it could be a system of spins coupled with a dipole-dipole interaction. And that was my first publication in Physical Review Letters. It's a prestigious journal. And the second kind of motivation for me was uh, I worked also on quantum thermodynamics. So trying to understand how we can use quantum effects to convert heat into a useful work. So some of the work that I did in that regard was interesting. Those are the two papers I was able to publish in Physical Review Letter. It's a very prestigious journal in the field. So those were the two kind of the early achievements in my career that also boosted my confidence. And then I also worked for a private company in quantum computing where I now you're not in the academic setup. When you are in private organization, you want to build a machine. So you want to solve the problems more in practical practical fashion rather than the academic fashion. And I was able to contribute into the research and development of that company. That was the third kind of important uh, milestone, I would say, that I can tackle industrial problems, not only the academic problems. So that gives you a confidence that the skills that you acquired during your academic career, you can also apply them in real world practical problems. But then I realized quickly that I have an academic mindset, and I'm in Dartmouth College now, and I think this is the best place where I can be because I'm doing experiment, and all the people working in this group, these are really smart people. So I also consider the work that I'm doing at the moment is will materialize that I would be able to categorize that as a milestone in future. Yeah. So there is nothing particularly I I I wouldn't say landmark because my career is always driven by my own interest. So if I feel like I want to work in quantum thermodynamics, I was able to find the positions in that area and work. I wanted to work in quantum biology, so I just work. So I think fulfilling the curiosity is more important. You you will automatically contribute to the field of science and technology if your curiosity is fulfilled there. So that's more important.
Yeah, so it seems like you and your interests have a really big impact on your career and like have made a lot of big landmarks in your career
Yeah,
because they're like the turning points that have led you to like different paths of science.
yeah.
And also speaking of technology, my next question for you is how has technology specifically impacted your current role in industry?
Oh, okay. Being a pure scientist, uh, working in a theoretical physics, of course, the only way you can appreciate what you're doing is by appreciating the technology, because most of this technology that we use, like laptops and cell phones, would not have been possible without the first quantum revolution. And the first quantum revolution, it's semiconductors, because it's just tunneling, right? So that the compactification of cell phones and laptop is not possible without that. So I always developed this sense of appreciation of the technology, uh, that you can build something using the ideas that you develop. Secondly, as a quantum theoretical physicist, I'm working in the field of quantum computing and quantum enhanced optimization. So this is like solving the practical problems of optimization, which are called as very hard problems in computer science. And so I get a sense that I am contributing to the technology because in order to solve those problems, like I will give you an example. There are these problems, like you want to do sample some probability distributions, or you have a salesman who would like to go from one city to another city to sell something, and if there is random distribution of cities, you want to go from one city to another city in such a way that you don't visit any city two times. So you want to find this optimal path. These are the kinds of problems which are important for medical science and logistics, right? These are the hard problems. So currently we are working on some things, uh, and interestingly enough, these hard problems have a very strong connection with theory of phase transitions in physics, because these problems becomes hard because when you are trying to solve them, you hit some kind of a dead wall sometimes if you're trying to do it with conventional machines. That is, if you translate that in the physics language, it's a phase transition. And so there is this very nice analogy between computer science and the statistical physics. And being a theoretical physicist, I find that more interesting and challenging to kind of focus on. So my knowledge certainly may be potentially useful to solve these kinds of problems. That's the biggest satisfaction anybody can have it, right? And it is in this sense you're also contributing to the technology, because if you want to make AI or any of these technologies better, you need computing power. If you need computing power, you want to explore the ultimate limits of computation. And if you want to explore the ultimate limits of computation, you have to have quantum mechanics, because the way we understand the world is that we either have things localized, like I can say that somebody somebody standing here or there, I can localize people. And another way we look at the world is things are like delocalized waves, and quantum mechanics is kind of a conflict between these things, which kind of gives you an advantage. So the ultimate to explore the ultimate limit of computation means the ultimate limit of any technology, right? Because any technology nowadays involves some kind of a computing. So there is an inherent connection with the technological advance. And definitely, whatever that you do in your career, however incremental it may be, it had some impact on the technology of future. Yeah. Sorry, I lost your voice.
Oh, sorry about that. Um, I just wanted to say that I can tell that technology has played a really big role with your career and that they're like interconnected in a way. So I can really tell that like technology has played a really big impact as on being a physicist, especially being a quantum physicist that
Yeah,
relies on quantum computers.
yeah, absolutely.
So my next question for you is, what advice would you give young people looking to enter this field, and what specific resources can you suggest?
Okay, for young people to enter into this field, first of all, always make sure that you're truly interested in this, not just because you hear about it in media or documentaries, because there is a lot of quantum computing stuff that you find on LinkedIn and media is hype. Okay. Quantum computing is not at a stage where you can use it for day-to-day life. Uh, there are some challenges to be accomplished in quantum computing, such as quantum error correction, which is absolutely essential for any kind of a true quantum advantage, right? So the first thing is, if you want to get into this field, try to understand what is hype and what is reality. See, we are living in the world of where algorithms are ruling on us, and they're creating biases about very many things. So understanding the difference between the hype and the reality is very important at this stage. Secondly, develop the curiosity, like just be curious about how world works. And if you're curious about how world works, you have to invoke quantum mechanics at some stage to explain how world works. So develop that kind of discovery approach of how things work. Then you can create your short projects. For example, how to send a rocket from here to moon. If you just try to explore this problem, you'll realize that there is a lot of optimization and optimal control involved in this process. So you can create a little project on this, try to understand how what are the stages in the moon mission. And then you will realize that all the algorithms which people use in these designing the moon missions, you also need similar algorithms in quantum computing, because you have to optimize things. So everything is all about optimization, right? So try to learn about these things through some practical projects. Like you can create some of your own project, learn some coding and share your codes on GitHub, which is a platform where people share their code. Other people can look at it, so you can develop in the coding skill and learn through projects. So passive learning, like learning by reading books is not very effective, but learning through projects, that is very effective. So try to develop this active learning habit because it will always help you to get into any career that involves logical analytical thinking, and quantum computing is no different than that. De- Develop the interest in mathematics because this is a highly mathematical, uh, but while you're doing mathematics, you also have to learn about how the mathematics is translated into what we do in lab. So have that curiosity that how things actually work, not only in the abstract sense, but in actual sense. So those are the four things I think to kind of this is the kind of thinking that you need in order to get into this if you're truly interested in doing quantum computing. And let me tell you one thing, you may want to do the career in quantum computing, but there are lots of other things like AI, machine learning, or other kinds of optimization problems in finance. All of them are very interesting. So you have to make your mind. I mean, are you oriented towards the academics or are you oriented towards the industry? If you're interested in applied industrial problems, think about whether you want to do PhD. I think doing PhD is always very helpful because you can get into industry with PhD degree. But if you are aiming for an academic job, then there are not that many academic positions because people don't retire. That's the one thing. There are very few positions. There is a lot of competition for funding, and you always have to keep publishing papers if you want to be in academia. If this it's something that you like to do, if you feel that this is your aptitude, then you have to orient yourself in the academic directions and understand from now how to write research proposals, how to get grants. So it's like how to advertise your research so that you can get money for your work and you can sustain a research group. That's the academic perspective. Industrial perspective, you just acquire background in computer programming, coding, learn languages like Python, learn some AI, and do some projects which are more industry oriented. And then you can take the path of the industry. You can do it while you are doing PhD. Definitely, it won't hurt. Doing PhD is always very useful, in my opinion. But just find your orientation, whether it's more academic or whether it's more industrial, and then channelize accordingly because many people don't know what to do after doing PhD, and they don't acquire these. Industry would require very different kind of skill set. Like in academics, you want to solve a problem, okay? In industry, sometimes the solution might be costly, so you want to do something else to save the cost. That's the difference between the academia and industry. So try to understand this difference and understand your orientation, and that's the key factor. And even then you are interested in quantum computing, even from the industrial perspective, it would be very helpful to get PhD in quantum computing because many of the startup companies are outcomes of the research that was done in academia. So you can definitely get the hands-on experience working on quantum computing theory, which is like essentially simulating quantum systems and the experiments doing in the lab. So this is learning about the instrumentation, learning about the dilution refrigerator, how to cool quantum systems to like few millikelvin temperature, how those devices work. That's the kind of understanding you can gain if you do PhD in an experimental quantum group. So uh, and that would enrich certainly your skills.
Your advice is really inspiring, and I can tell that you have like a lot of thoughts about it. Um, we're almost at the end of our interview time, so just before we leave, I have one quick question. So I know you talked a lot about developing like analytical skills, experimenting, and like developing engineering skills for the industry.
Mhm.
So how do you think students can develop these skills while they're still in high school?
Yeah. So as I said, you can always design your own project. So for example, I gave you an example of moon mission.
Yeah.
It's a very difficult problem because when you send the spacecraft on moon, it goes through the stages, right? Then you can compute, you can come up with a project. Okay, what are the fuel requirements for this spacecraft? Uh, how can I optimize the fuel? What's the orbit? What's the payload? And that gives you a sense of, try to always get a sense of what, if you want to solve a problem, what are the steps involved? How do you formulate the problem? Once you formulate the problem, what are the steps? How can you answer that question? So, how can you divide it into steps and then develop the tools which are required to fulfill each of these steps? And then you will gradually build the understanding. Uh, there is no magic to solving a problem. Okay. The only key to unlock secrets of anything is to understand the whole process. Without understanding, you cannot make progress. And especially, I would like to give this advice because now we are living in the age of these AIs and chat GPTs, where people are just blindly using chat GPT and they think that, or Google or WhatsApp, and they can kind of get carried away with whatever information the chat GPT is giving them. They treat that as a knowledge, right?
Yeah.
So try to avoid this trap and like focus on thoroughly understanding the problem by yourself, not by using the chat GPT or any other tools. And then definitely once you understand the problem, once you formulate the problem, then you can use tools like AI to come up with steps, or let's say you want to develop a code and it's a mechanical process, you can use ChatGPT to do that. But you have to make this very rational choice of not using ChatGPT and these things, but formulate the problem on your own. Like developing logical and analytical thinking requires solving more and more problems. That's what I would do. I would just try to solve problems, different kinds of problems. Like, for example, I would try to understand different hard problems in computer science, what it means, why are they hard, uh, why quantum computing is required, why not conventional, why conventional computing doesn't work. So you can ask these questions on your own, and then you can find resources to read about it and develop and understand. That's the way you can learn. And we learn by pattern recognition. Remember always, we learn by pattern recognition. So try to find patterns in whatever you're reading, whatever you're learning, and that's how you will. Like, I will give you an example. Today we use laptops and computers, but we built a computer when we did not have computer, right? We didn't have computer. How did we build such a complex machine? We built it by thinking. We built part by part. We built the transistors, then we built logical gates, then we understand how it works, and everything just came together. So, dividing a problem into small steps and understanding each and every component, understanding is key. Without understanding, you cannot build anything. So, always focus on understanding anything that you're doing. That's the best advice I can give.
That's some great advice, in my opinion, because I completely agree with you that understanding like the problem, understanding what's actually going on is really important. Because
Yeah.
if you don't understand that, then like you can't really do anything about it because you don't understand it enough to do anything.
Yeah. Shooting in the dark is a very bad idea. You
Mhm.
can shoot yourself if you're not careful. So,
And that's gonna be it for today. So that was all the questions I have. So thank you so much for taking the time to be here today,
yeah.
and I hope you have a nice day.
Yeah, no problem. Thanks for
I'll see
inviting
you.
me.
All
And
right.
feel free to send me emails if you need specific information about quantum computing. I would be very happy to help anybody who can get in touch.
All right.
So, thank you very much for inviting me, and you have a good day.
Have a good day too. I'll see you.